In order to solve an equation that has two radicals, then we have to get rid of each radical one at a time. So the process that we've used to get rid of radicals is to isolate a radical and then square both sides. So in this case, we already have one of the square roots by itself. So to get rid of that square root, we're going to square both sides. But if we square the right side, we also have to square the left side as a whole. So on the right side, the square root and the square cancel, leaving us what's underneath the radical. But on the left side, in order to square this, we don't simply square each piece, but we have to multiply it times itself. So the radical minus 1 times the radical minus 1, like this. And we have to distribute to multiply that. So we're going to do the radical times itself. Now, remember, anytime we multiply something times itself, it means we have that item squared. So in this case, we have this square root times itself, so this square root squared. And remember what happens when we square a square root, those cancel. So we're left with what's underneath the radical. We're going to distribute that square root times minus 1, so that'll give us minus 1 times the radical. Then we're going to distribute this minus 1, so minus 1 times the radical. And minus 1 times minus 1, which will be plus 1. And then we bring the other side down. Now let's combine like terms on the left side. We have a 3x term. We have a 4 plus 1, so a plus 5 term. And then we have two of these. So minus 1 more will be minus 2 of the square roots. And then we have 2x plus 1 on the other side. Now, it does not matter which side we get things on. We can get the square root on the left side, or we can get the square root on the right side. Since this square root has a negative in front of it, it doesn't matter. I'm going to move it to the right side so that it will have a positive in front of it. So let's add that square root to both sides. Add that square root to both sides. So that makes those go away. So since we want that square root by itself, we don't want this on the right side. So we're going to move it to the other side. So take 2x away from both sides and take 1 away from both sides so that those cancel. So on the left side, the square roots canceled. That's going to leave us 3 minus 1, 2, so 1x, 5 minus 1, so positive 4, and then 2 of the square roots on the other side. Now, it's not completely a requirement that we get rid of this 2, but so that we can be consistent in isolating our radical, let's divide both sides by 2. That will make those go away. So that's going to leave us the square root on the right. If we were to divide by 2, we would have to divide each piece by 2, and we've done that on other problems. But notice this leading term, which has a coefficient of 1, if we divide it by 2, that's not going to reduce. So we can just leave that as x plus 4 over 2. So now that our radical is isolated, to get rid of the square root, we square it. And if we square the right, we also square the left. So when we square the right, the square root and the square cancel, leaving us 3x plus 4. If we have a fraction, we take the top and square it, and the bottom and square it. So on the bottom, 2 squared, that's just 4. To square the top, I'm going to come over on the side. To square x plus 4, we have to do x plus 4 times itself. Remember, that's not just x squared plus 4 squared. That's x plus 4 squared, so x plus 4 times x plus 4. So we can distribute the x squared plus 4x, and then distribute the 4. And when we combine like terms, we have an x squared on top. 4 plus 4 will give us 8x, and plus 16. On the other side, we have our 3x plus 4. So we have gotten rid of the square root on the right side. We fold out the numerator on the left side. Since we have a fraction, we can get rid of that 4 because the opposite of dividing by 4 is to multiply by 4. So we can multiply both sides by 4 in order to cancel those. So that leaves us x squared plus 8x plus 16. And if we distribute the right side, we're going to get 12x plus 16. So we have gotten rid of our radicals, we've gotten rid of our fractions. Our equation is quadratic because of that square, so we want to get everything on one side. So since the x squared is positive on this side, we want everything over here. So we can take away 12x on both sides for those to cancel. And we can take away 16 on both sides for those to cancel. And that will leave us x squared minus 4x. Those cancel, and that leaves us 0 on the other side. So once we have a 0 on one side, we factor the other side. So we have a common factor of x. So if we take an x out here, we're left with an x. If we take an x out here, we're left with a minus 4. Set each factor equal to 0. So if we set the first factor equal to 0, x is already by itself. If we set the other factor equal to 0, we can add 4 to both sides and get x equals 4. All right, so the only thing left to do is to check to see if both of those answers work. So this is our original equation, the black part here. So if we check x equals 0, I'm just going to talk through this. 3 times 0 is 0 plus 4, so that gives us 4 under the radical minus 1. On the other side, 2 times 0 is 0 plus 1, so that gives us 1 under the radical. So the square root of 4 minus 1 equals 1. And that's true. That's a true statement. So 0 is a solution. Now let's see if 4 is a solution. So if we enter a 4, 3 times 4 is 12, plus 4 is 16 under the radical, minus 1. On the other side, we get 2 times 4, that's 8, plus 1, so 9 under the radical. So 4 minus 1, and that is a true statement as well. The square root of 16 is 4. The square root here, that's a true statement. So x equals 4 is also a solution. So both of those work in this case.